Okay, so welcome back, and now let's do another example of where we want to determine the intervals of convergence for a function. So here we're given the function. Now, again, remember, we're dealing with a square root function, okay? So we know that what is the domain of this function? Well, the domain of this function, remember, we have to have all non-negative values. Right? What are the non-negative values of this? Okay? Well, we want 4 minus x squared to be greater than or equal to 0. So if we solve for x, what do we get? We get what? Negative x squared is greater than or equal to negative 4. If we divide both sides by negative 1, we get x squared is less than or equal to 4. Now, if I take the square root of both sides, I get x is less than or equal to plus or minus the square root of 4, which means x is going to be less than or equal to plus or minus 2. So that means the domain is going to be what? Hold on a second. This is, hold on, because I'm dealing with a square with an inequality less than or equal to, this is actually going to be the absolute value of 2. Oh, hold on. This is going to be the absolute value of 2, which means, or no, how do I want to do it? Oh, no. Let's do it this way. Yep, sorry. I want the absolute value. The easier way to say it is, since this is a square, I can say that the absolute value of x is going to be less than 2. Okay? So if you take the square root of both sides, another way of writing it is the absolute value of x is going to be less than or equal to 2. So now, what do we get? We get x is less than or equal to 2, or we get negative x is less than or equal to 2, which also implies that x is greater than or equal to negative 2. And so that gives us the interval of negative 2 to 2. Now, that's the domain. Now, the thing is how do we know it's continuous on this domain? Well, that's where we have to look at the limits. Okay? So by using the limit laws, so again, this is one way to find the domain, right? Which gives you an interval to consider. So now that we've got the interval to consider, now let's use the limit laws. So we say limit as x approaches 2. A. So notice this, A. Okay? So remember, we know from our limit laws that the limit of as x approaches a of 4 minus x squared is going to equal the square root of 4 minus a squared. Right? That's just from the limit laws. Okay? And that's going to be true for all values of a, right? Okay? And this symbol, by the way, this symbol means element of. Okay, just a little bit of shorthand. So this is going to be true for all values. So another symbol is the upside down A. So that means for all values of A in this interval. Okay? Okay, so that takes care of the open interval from -2 to 2. But what about the endpoints, right? So we've got to test the endpoints. So, oops. So now we've got to take the limit as x approaches what? -2 from inside the interval. So we're going to go from the left of 4 minus x squared. Now, if I approach this from the left, well, guess what? What do I get? This is going to give me 0. Now, also, what if I do the other endpoint as x approaches +2 from the... Oh, hold on a second. Nope, this should be from the right. I'm sorry, I got these backwards. Okay. So I'm going from -2, I'm going to be approaching it from the right, and down here I'm going to approach +2 from the left. And so again, if I do that and I just plug in my value, I again get 0. Which is a real number, right? So the limit exists, so therefore it's continuous. Okay? So it's continuous from the right at -2, and it's continuous from the left at +2. And so therefore, the interval of continuity is -2, 2 with square brackets. And that's it. Have a great day.